All right. So everyone, today, all right, we're going to talk about combining like terms with word problems actually. So very interesting. Okay. So let's get to it. Okay. All right. So here we go. Now, yesterday or depending on how things fall out, this might be part of a video from the same day or a video from for the next lesson. Okay, so this is something you will see, and I always hesitate because I want to do this with the seventh graders always, but there's never enough time to do that. So today what I want to talk about is solving consecutive integer problems, which is a Algebra 1 exam topic. Okay, and you might be wondering, wait, what's going on? Why are we back doing integers? I thought we're combining like terms. You'll see. Okay, so all right, first of all, let's get the definition down. What does consecutive mean? Right, it means one right after another, right? So for example, could you give me two consecutive numbers? Right, 1 and 2, right? Could you give me three consecutive numbers? Right, 1, 2, and 3, meaning one right after another, right? In increments of 1. So 1 more than 1 is 2, 1 more than 2 is 3, right? Okay, so that's what consecutive means. So that begs the question, find two consecutive numbers whose sum is 21. Can you guys think of two numbers that adds up to 21 that comes right after one another? Yeah, 10 and 11, right? Now, look at this next question. Can you find three numbers, one right after another, that will give me 9? Is it 2, 3, 4? I know what some of you are thinking, right? You're probably doing this in your head right now. Is it 2, 3, 4? Yeah, that's exactly it, right? So some of you might try 1, 2, 3, 3, 4, 5, and so on and so forth, right? So it's 2, 3, and 4. So here's the question, though. What happens if the numbers are so big, like 263, 246, 196? I mean, you're really gonna spend all that time, even if you have a calculator, you're gonna spend all that time looking for those consecutive numbers? You're not, right? So one way that we could use algebra to help us is by using this, okay? So think about this. Now, let's say the first letter, right? Actually, let's take this back up one level. Let me use a different color. So let's say we have three numbers, right? Let's say they're 1, 2, and 3. Let's say we use the letter n to represent the first number. So let's say n is the first number. All right, now the one itself is the number, so don't confuse the 1 with the first number, okay? Let me ask you this. What algebraic expression could you use to represent the next number using the same letter? Okay, I'll repeat. What algebraic expression can you use to represent the next number, the 2, by using the same exact variable, the letter n? Can you guys think of one? Yeah, n plus 1, right? Because the number after the first one, n, will be n plus 1. Now, think about that. Still using the same letter. What would be the next number? What would be the expression for the next number after 2? What do you think it will be? It will be n plus what? Yeah, n plus 2, right? And you know you're right because 1, right? N is 1, so 1 plus 2, that's 3, right? So remember this, right? Now, with that said, right, if I say the sum, right, find two consecutive numbers whose sum is 21, I got my first number, and I got my second number, right? It's only two numbers, right? Remember. And if I were to add these two guys together, I'm supposed to get 21, right? So watch this. N, right, first number, plus the second number will give me 21, right? So look at this. What topic is this? OMG, right? This is combining like terms. This is why we have to do this topic in combining like terms. So let's add it. N plus n is 2n plus 1 equals 21. And then you solve it. All right? Another reason why we have to review two-step equations. And then we have 10, right? Isn't that right? Right? 10 was the first number, right? We have it here. It's here. 10's the first number. 11's the second number. How do I know? N plus 1 is 11, right? So that's how you would do that. So let me leave that up here so you guys can refer it should you need to. Look at this next one. Find 3 consecutive integers whose sum is 9, right? So n is the first number. N plus 1 is the second number. Plus n plus 2 is the third number, right? First number, second consecutive number, third consecutive integer. It's integer too, by the way, right? Whole numbers. Is 9, right? Is 9. So combining like terms, n plus n, that's 3n. There's the bell. 1 plus 2 is 3 equals 9. Subtract 3, I'm going to take it to the side. I'm just solving here. There you go, 2, right? Remember that? 2, right? N plus 1 is 3, right? And n plus 2 is 4. 2, 3, 4. 2, 3, 4. Okay? That's how you do it. Now, let me erase the previous example here. Let's see. Now, hopefully I don't accidentally erase too much. Okay. All right. Yeah, I think that's it. Okay. All right. Let's keep it going. If you want, you can try this one on your own. And by the way, you can check your answer, right, without even consulting the teacher, because you would know, right, once you add it. 2, 3, 4 adds up to 9. 2, 3, 4 adds up to 9, right? So if you want, you can try this one. You can also try the one after that on your own. Okay? You probably don't have to. If I'm skipping it, then I'm either not wanting to do it at all, or I might save it for class. Okay, so you don't have to do those two actually. Unless you really want to do it on your own, then you can press pause and do that. Now it gets interesting. So again, I'm using these really large numbers because I want you to try that. Now it gets really, really interesting. Look at this. Find 2 consecutive. Now, I don't know if you noticed, how is this question different from this question? How are these 2 questions different? Can you guys tell? What's the only difference? Yeah, even, right? So what are consecutive even integers? Let's talk about that first. 2, 4, 6, those are consecutive even integers. 10, 12, 14, those are consecutive even integers, right? And then let's talk consecutive odd integers. What are consecutive odd integers? 1, 3, 5, right? So I'm skipping 1, in other words, right? So you know how, like, maybe not anymore. So when you used to have a textbook and your teacher would say, do page 126, odd, right? So you do all the odd numbers. And then they say, do 127, even, right? 2, 4, 6, right? So on and so forth, right? So what's another set of odd integers? 101, 103, 105, right? Just want to get that out of the way. Let's see how we're doing on time. Okay, all right. So find 2 consecutive even integers. Right now, here's the trick, right? If n is the first number, and I'm going to use a numeric example, what would be the second number? Like, what expression would you use to represent that? So to help you with that, let's use real numbers. Let's say we do 2, 4, 6, right? 2, 4, and 6. Okay. Now, let's say n is the first number, which happens to be 2. What's the expression using the same letter that will give you 4? Yeah, plus 2, right? What about 6? Yeah, n plus 4. So you see how when we have just good old consecutive numbers in general is n plus 1, n plus 2. With even integers is n plus 2, n plus 4. Okay, so keep that in mind. Now let's combine some like terms here. N plus, so first number, second number, right? The second consecutive even integer is 246. All right, so that's 2n plus 2 equals to 246. Subtract 2, so that's 2n equals to 244. Yeah, divided by 2 is 122. So the first number is 122. What will be the next number? 124. Right? Now let's see if we're right. Let's add these two. Yep, 246. These two add up to 246. Okay? That's how you do it. Now, how is this question, let me use blue. How is this question different from the one in purple here? How are they different? Do you notice anything? Yeah, odd, right? So 135, right? Like I mentioned before. Now, here's the thinking exercise for you. If n still stands for the first number, what would be the second number that's odd, right? The next odd number. What would that be then? What would this need to be? Now, I'll tell you what the wrong answer always is, right? N plus 1. People always think the next number is n plus 1, and what do you think the third number would be? What do you think most people would say? Yeah, n plus 3, but that's not true. Why? Take a look. Let's say we're doing 135, right? First number is 1, right? What do you think the second number is? Yeah, it's not plus 1 because that would be 2, right? But this is not 2, this is a 3. It's n plus 2 still. It's the same thing. And what about the third one? Yep, n plus 4. Notice how this doesn't change? Okay, all right. So notice how this doesn't change. N plus 2, n plus 4 for even and for odd. Same thing. Okay, so what does that mean? Well, that means we have to solve it. So we have to add these 2, right? n plus 2. Is it just 2? Yeah, it's just 2. So n plus 2 equals to, what is it? 196, right? Let's see. Yep, okay. So that's 2n plus 2 equals to 196 minus 2. 2n equals to 194. Let me get that calculator. Oh, I don't have to. I don't need that. All right, let's see. What is that? 297. Is that right? Yeah. Right? Odd number, right? So, yeah, it just worked out. So 97, what's the next odd number? 99. It's 97 and 99. Okay, now find 3, so let's save these for later. Okay, we can do it in class or I'm gonna skip it altogether. But the idea is the same, right? Consecutive odd, n plus 2, n plus 4. Okay, so hopefully you'll remember how to solve these kind of questions. Now, how should I, yeah, let's save the regions questions. I really don't know. Should I do regions questions? It's 13:21 already. Yeah, let me stop. Okay, all right. So if I need to do this, I'll either combine the videos or do it in a separate lesson. Okay, all right. Thanks for watching. Bye-bye.
OMG, that was so good.